अब जागो तो सब जागो, अंबर तक यही नाद गूंजेगा, अंबर तक यही नाद गूंजेगा, अंबर तक यही नाद गूंजेगा, अंबर तक यही नाद गूंजेगा। हाँ अब मेरी बारी है, मेरी जिम्मेदारी है, आंखें गाढ़े सच के साथ हूँ खड़ा, मिटने की तैयारी है, अब तो लंबी पारी है, सर पे जोश अब होश का चढ़ा, अब बदले तो युग बदले, अब बदले तो युग बदले।
Join us as we venture across the great Indian technology outback. We visit the country's premier research labs and find out about the latest innovations. All of them have a global impact, all of them designed by Indian scientists. In Bangalore, a nanotechnologist has for the very first time generated electricity by placing carbon nanotubes in the blowing breeze. It could be a new, never-known-before source of alternative energy. In Mumbai, a chemical engineer's fascination for soil and water and how the two can be used to create a green technology that treats Mumbai's sewage. It could change the face of sanitary engineering. Down south in Chennai, the world's first $100 personal computer. It could transform the way we use computers forever. And finally, in the country's capital, New Delhi, a team of researchers has developed a unique water-based compound that can revolutionise the treatment of brain tumours. It could be one of India's biggest techno-medical breakthroughs in recent times. At the Indian Institute of Science in Bangalore, Professor Ajay Sood has been turning students into physicists for the last 20 years. This is where the thrill of fundamental science has come alive for him every day. It's here that this nanotechnologist has found his true calling.
My excitement and my thrill is really doing the basic science at the cutting edge.
As a physicist, Ajay Sood has always been fascinated by the world of nanotechnology.
If you just give a Google search, if you just say nanoscience, you get a very large hit in about 0.06 seconds.
It's a world that's invisible to us, because it exists in dimensions that are easily 100,000 times smaller than human hair.
So we are talking about very, very tiny length scale.
In 2002, Professor Sood made a startling discovery about the carbon nanotube.
This is the simplest way to imagine the formation of a nanotube. This carbon nanotube is a single element laboratory for nanoscience and nanotechnology.
When Professor Sood and his team set up an experiment with carbon nanotubes in their lab, they knew they were working with a miracle material. Here was something that conducted electricity better than metals and boasted of a strength stronger than steel. But Professor Sood was interested in something else. What would happen if one were to flow liquid over these carbon nanotubes? The results were dramatic. The flow of liquid around the miniature tubes generated electric current.
You can now use these nanotubes as a voltage source, which means that when the liquid flows, you generate voltage and current.
The discovery was patented in India and the US. One of the most exciting applications that could emerge from this technology is the possibility of a carbon nanotube heart pacemaker. This can sit in the human body and generate power from blood instead of batteries.
When we were doing this experiment, we also kept on asking ourselves, okay, if the liquid flow is generating voltage, what will happen if we flow gas? It's very natural because liquid and gas both are fluids.
The hypothesis was right and wrong. Gas flow over carbon nanotubes did generate electricity.
Let's say check the polarity.
But the results from the liquid flow and the gas flow were very different. It wasn't supposed to be.
Why such a large signal?
Why didn't the physics make sense?
Something new physics entering into the scene. And that physics we don't understand right now.
It was time for some introspection.
So we did the experiments with different gases, different types of nanotubes, different sources for nanotubes, and lo and behold, every time we got the same results for the gas flow.
The mystery of gas flow over carbon nanotubes almost remained unsolved. It seemed like this time there would be no eureka moment. Until one day, Professor Sood picked up a physics classic. And there, the answer stared right back at him. It was college physics and Bernoulli's principle at work. That explained the deviant results and made way for another patent, now known as the famous Sood effect.
Once we realized that the physics which is operating is involving Bernoulli principle and Seebeck effect, then immediately we did the experiments on semiconductors. And to our biggest delight, we found the effect is even bigger in some semiconductors than nanotubes.
As soon as research papers were published in various science journals, the technology had potential buyers. Prasanna Chittoori of Trident Metrologies in the US met up with the professor to discuss the development of gas flow sensors that could be far superior to existing sensors in the market.
And what's the limit of this laser?
Oh, this is the same. What is happening? The ends will react and dissolve.
This thing is so simple. It's amazing. No one's thought about it before. The fact that you can take some carbon nanotubes and or silicon and put it in a blowing breeze and generate power is such an attractive idea.
Chittoori also has plans of developing an alternative energy generation model with this technology, although that might have to wait a while.
The power that's generated from each of these Sood elements today is very small. So to be able to scale this up and integrate several elements where we can make this economically viable is a serious challenge, and we are in the process of putting a team of engineers together that can work on this.
For technovators like Professor Ajay Sood, the thrill of fundamental science lies in the idea and its scope, where there is a beginning. But the end is just a collage of possibilities. Mumbai's 18.3 million residents dump out 1,700 million litres of sewage every day. The world's third largest city is getting crowded, going grey and losing her greens. Tucked away in the middle of this mayhem is an unexpected patch of green, the Indian Institute of Technology. Stroll down a wild trail and it isn't difficult to spot Professor Shankar lost in thought. For decades, this chemical engineer has been intrigued by soil and water and how the two can be used to create a green technology that treats Mumbai's sewage. He believes the solution lies in the mathematics of ecology and evolution.
There is very little life in water. In terms of numbers, it looks like something like 1 to 5 billion tons. In comparison, in land, there is something like 650 billion tons of life, measured as carbon. So, this difference in numbers gives me some understanding of how life has evolved over the last 4 billion years.
As the professor spent time contemplating about the evolution of life on land and water, it struck him that water cannot sustain dead matter.
What happens in water is that there is a huge number of food chain that is working in water. Small organism being eaten by larger organism, and larger organism being eaten by even larger organisms, and so on, so that the largest organism, maybe a whale, they come to land and die, showing that there is practically no death in water, while death is common in soil.
Why does land process the dead better than water? Why does it take a lot more effort to survive in water than land? The carbon cycle seemed to suggest that water isn't the most natural or the most efficient way of getting rid of dead organics. Yet it puzzled the professor that sanitary engineering methods all over the world use water for waste disposal.
Sanitary engineering of the last 100 years are creating various difficulties for urban communities, and therefore an alternative is required.
Professor Shankar's field visits offered an alternative solution: soil biotechnology. If nature uses microbes in soil to process dead matter, soil biotechnology would mimic nature. It would use soil to purify water.
We are looking at a technology which will consume very little energy, which will mesh or which integrate with the natural cycles of our environment.
As soil biotechnology moved into its research and development phase, Professor Shankar and his team set out in search of the most critical ingredient: the right soil. They were looking for soil that would conduct water without getting choked. It also had to have the right mineral composition.
Yes, this has got the right composition, the right hardness.
Apart from the right soil, this technology requires microbes in the soil to process waste organics. This is done by cultivating the carnivore of the soil, the Geophagus worm. These worms feed on soil bacteria to maintain the microbe population of the soil. The team had cracked the technology on paper, but it took a while to artificially construct the biochemistry of nature in the lab. The main ingredients were almost in place. The challenge was now to continuously generate oxygen, reduce atmospheric carbon, create soil and purify the water.
Our interest in soil biotechnology is to be able to construct an ecosystem which resembles nature.
6 years later, the team was ready to construct the largest soil biotechnology plant. This would be for the Worli sewage pumping station of the Bombay Municipal Corporation that pumps out almost 800 million litres of sewage into the sea every day. It was going to be a massive transformation. Professor Shankar's experiment had worked in a test tube in the lab, but would it work on 5,000 square metres of land? It was a risk the BMC was willing to take.
Soil biotechnology is a new concept that water is allowed to pass through different layers or filters. This is a unique plant. So far, nobody has constructed this type of plant.
7 months and 2.9 crore of rupees later, the pilot plant was ready to be tested. At first glance, it looked like a well-manicured garden. A closer look, and it was really 3,000 square metres of specially constructed ecology. Soil loaded with microbes, additives and plants. This was watered by pipes that spurted out 3 million litres of sewage every day. It took about 8 hours for the soil to filter all the sewage and fill up the storage tanks with purified water.
Compared to other technologies, this plant is producing very clean water. Plus, there are no foul odors and no sludge to be disposed of, which is still a problem with other technologies.
While soil biotechnology may not produce drinking water, it does create an evergreen factory that treats a city's sewage to produce clean water for construction and agriculture. It is also price and space efficient. Maintenance in terms of power, labour and additives works out to 3.5 rupees for every 1,000 litres of sewage. This is less than half of other technologies.
Based on the success of this plant, we are going to have some more plants in Mumbai city at Ghatkopar pumping station, Bhandup pumping station, Warsaw pumping station.
Professor Shankar believes this technology can change the face of sanitary engineering globally, as unlike other waste treatment methods, soil biotechnology saves energy, produces oxygen and gets carbon credits.
We are looking forward to setting up more and more such plants in different parts of the country as well as in different parts of the globe. And we are looking at our big users, which are the corporations of the cities of the world, as our major customers.
Every morning for the last 5 years, Jay Raj and his wife have been a regular sight at this Chennai suburb. From steamed rice idlis and mint chutneys to freshly fried puris and sambar, their street food stall is very popular amongst the locals. With few overheads, Jay Raj manages to make almost $200 every month. It isn't much, but for this 34-year-old entrepreneur who only studied up to high school, this is licensed to dream big. He aspires to scale up soon and own a small snack shop in the neighbourhood. He also wants to make sure his children get the education he never got. Jay Raj dreams of going beyond his modest middle-class suburban existence. This street food vendor doesn't only dream, he surfs, he chats, he gets online. Jay Raj has just got himself a personal computer with access to broadband internet, all for just $100. Along with 300 other families, he's part of a pilot project in Chennai.
What customers have at their home is a monitor, a keyboard, mouse and this device which is called a NovaNet PC.
That sets out to make computing easy and affordable with the world's first $100 personal computer.
Cost of the computer has drastically been reduced just because of the change in technology.
They are among the next billion PC users who, until now, hadn't ever owned a computer.
NovaNet PC வந்து என் வாழ்க்கையை சேஞ்ச் பண்ணியிருக்கு. இது வந்து நான் வாங்குவேன்னு நினச்சி பார்த்ததில்ல. 4500 ரூபாய் கிடைக்கும்போது நல்லா யூஸ்ஃபுல்லாக இருக்குது, விலையும் கம்மியாக இருக்குது, எல்லாருக்கும் யூஸ்ஃபுல்லாகவும் இருக்கும், எனக்கு யூஸ்ஃபுல்லாக இருக்குது.
The concept of computing for the next billion PC users was a refrain that was often heard in the hallowed corridors outside Professor Ashok Jhunjhunwala's office at the Indian Institute of Technology in Chennai.
What we really need is to use internet to transform villages. We have kind of summed it up and sort of saying that we would like to see that the per capita rural GDP doubles in 8 to 10 years. That's a kind of dream with which we are focusing on.
A decade ago, Professor Jhunjhunwala's Telecommunications and Computer Networking Group, better known as TENET, had revolutionised telephony in rural India. Today, the same group is working towards making wireless broadband internet accessible and affordable across the country by 2020. The $100 personal computer is one way of achieving this target.
We had realized several years back that to get broadband to the middle and lower middle class, even in urban areas, forget about rural areas, it will require solutions different from the normal personal computers.
In 2004, Jhunjhunwala's team collaborated with engineers from Novatium, a company set up solely to develop the prototype of the $100 computer. The group was in search of a PC that not only functioned like a normal desktop, but was also much cheaper and simpler.
First thing that we are really looking at is a full functionality PC. We are not talking about a stripped down. Everything that you can do in a reasonably advanced PC, you should be able to do that. The second thing that we are looking at is something which can be turned on and off, where you don't need to shut down. It's like a television. You turn it on and off. The third thing is that it should provide a complete solution. The connectivity should be there, everything should be there. I shouldn't have to do anything.
In the beginning, this seemed like an impossible brief. How do you manufacture a cheap PC without compromising on its memory, processor and software applications?
Let's start it from scratch, from ground zero.
It would take a few months, many experiments, and several brainstorming sessions to arrive at a solution. The Net PC.
If we don't solve, I'm extremely proud that we have put all the effort which we can to solve this problem.
This would be all about cheap cell phone chips and thin client network computing, a concept that has often been used in offices but had never made it beyond that. Thin client network computing meant that customers like Jayraj would only have a monitor, keyboard and a small black box at home. This would be connected to a central network server a few kilometers away that would network other customers, run software applications and store data. As these thin clients don't have hard drives, they don't require fast and expensive processors like Celeron or Pentium. The cheap cell phone chip, which costs under $10, does the job just as well. The first prototype of the Net PC was on the shelf by mid-2005. It offered 3 operating systems: Linux, Windows and Solaris. Choose any one and the desktop throws up the normal array of applications from web browsers, chat messengers, multimedia players to word processing and office spreadsheets. And all these software applications are on a central network server. They will always be updated and virus-free.
You buy an equipment which will not age, which will not really, you have to throw it out after 3 years. So it's all plus and plus beyond that for the consumers.
Novatium and Jhunjhunwala believe that the next billion PC users of the world will skip the desktop PC and go straight to network computing.
Imagine a typical Indian middle class earning about 8 to 10,000 rupees, a single income family, and the computer is something they've never owned till now. They've only seen the rich kids using it at their homes. And this is where I think no one at PC manages to build a strong emotional connect. So now they feel a sense of pride owning the whole thing, and there is a certain status symbol that comes in along with owning the no one at PC. And I think this is going to be the single biggest success factor as we go along.
While other computer manufacturers strive to make their components cheaper, Novatium's approach has been to look at the problem from a completely different angle.
I think there are different approaches to this as well. And I think Novatium approach is unique, which is completely different than what Intel is trying to do, what Negroponte is trying to do. They're more on the device side. They're trying to make a computer cheap, whereas we are trying to make computing cheap, which are two different things altogether.
Walk into any operating theatre at the All India Institute of Medical Sciences Neurosurgery Department, and every fourth operation will be to remove a brain tumour. The country's premier medical research institute in Delhi gets about 760 cases of brain tumour every year. In many cases, the tumours turn out to be malignant. When this happens, brain cancer can be one of neuroscience's most recurring nightmares.
Once you operate, remove the tumor, within a few weeks or months, it's grown back to its size or maybe larger than before. We cannot operate many times on the brain. Maybe we can do it twice or thrice, not more than that.
After the surgery, most patients with brain cancer have to deal with chemotherapy and its dreaded side effects. In this treatment, the drug is administered orally or is injected into the body. Once it enters the bloodstream, it circulates all over and destroys the cancer cells in the brain. But it also manages to kill other healthy cells along the way.
We are looking for a way to deliver the chemotherapeutic agent right inside the tumor, inside the brain, inside the tumor, so that it doesn't affect the other parts of the body.
A trio in Delhi is already at work on the problem. The team includes a polymer chemist and a biomedical scientist from the Indian Institute of Technology, along with a pathologist from AIIMS. They have been developing a solution with hydrogels that could revolutionise the treatment of cancer, brain tumour and bone infections like osteomyelitis. The hydrogel's claim to fame in the medical world has been through breast implants and contact lenses. This water-based compound has the ability to store proteins, vaccines, hormones and other similar molecules. The premise of this research was simple: load these hydrogels with the drug and insert them directly into the brain. But the search for the right hydrogel and its ingredients turned out to be complicated.
There are three important points we thought we should actually look for. One is its biocompatibility. That means it should not have any kind of toxic reactions of the body for the body and other system. Second is that its biodegradability. That means it has to be degraded inside the body over a time period. And third is its affordability, because that is also very important if you want to use it in a country like ours, a developing country.
The first phase of the research began in 2002 at IIT's Polymer Science Lab. This was ground zero, where Professor Veena Chowdhury and her team began by sourcing ingredients that would be easily available and affordable. Their experiments seemed to suggest that gelatin and acrylic acid were most likely to fit the bill.
About 100 permutations and combinations were made, and we found that few has to be discarded because of their poor strength, few have to be discarded because of their very fast degradation.
Most of these hydrogels didn't work. The ones that did made it to the next stage, Professor Veena Cole's bioengineering lab.
My role as a biomedical scientist is to see that the polymer degrades or the polymer shows biodegradation and have a control or sustained release of drug for a stipulated period of time.
Professor Cole's team had an exhaustive task at hand. Every hydrogel sample that arrived from the polymer lab had to be extensively tested to check if it could release the drug at the correct rate. After many rounds of elimination, the final few hydrogels left the research centres at IIT and made it to the next stage of testing. Dr. Amit Dinder's pathology lab at AIIMS would be where they would be tested for biocompatibility.
After we dissected out or we selected out these 4 or 5 good hydrogels, then we further carried it to the animal experimentation.
The final 5 hydrogels had worked well in the lab, but would they behave just as well in animals? No one had an answer yet. A couple of rats and rabbits, displaying symptoms of a bone infection called osteomyelitis, were picked up from their colonies and brought in for the experiment. Dr. Dinder believed if the antibiotic-loaded hydrogel could be directly inserted into the infected area of the bone, it could be treated much faster and without the usual side effects of the drug. But strangely, the drug-loaded hydrogel implants didn't seem to work as well on the animals. It produced toxic reactions in the rabbit. 2.5 years of development work suddenly seemed meaningless.
That point of time we were really disheartened.
It took the trio 4 years to arrive at the perfect hydrogel. At less than $1 per gram, this gelatin-based compound is many times cheaper than its US counterpart, which is priced at over $3,000 a gram. In the next 6 months, the team hopes to start clinical trials on patients with brain tumours. If it's successful, this will potentially be one of India's biggest technomedical breakthroughs in recent times.
अब जागो तो सब जागो, अंबर तक यही नाद गूंजेगा, अंबर तक यही नाद गूंजेगा, अंबर तक यही नाद गूंजेगा, अंबर तक यही नाद गूंजेगा। अब मेरी बारी है, मेरी जिम्मेदारी है, आंखें गाड़े सच के साथ हूँ